Hello, welcome to Einstein's Mechanics. In this episode, we are going to start with our probability class. And our first thing to look at is the arithmetic mean. When we talk about the mean, we are trying to find a location where a concentration of a data is. Are we okay? So our first point is that the arithmetic mean is used to measure locations. Are we okay? So its main aim or the function is used to measure locations. In this episode, we are going to focus on random discrete variables. Random discrete variables. When we talk about random discrete variables, they are the variables that can be listed as we have x1, x2, x3 up to xn. These are random discrete variables. They are ungrouped data. When we talk about grouped data, you can say something like from 20 to let's say 30, from 40 to 60, say from 70 to 80. These are grouped data. Are we okay? And these are random discrete variables. So in this episode, we are focusing on random discrete variables. In the next episode, we'll talk about group data, how to find the arithmetic mean. So for the random discrete variables, if we are given variables from x1 up to the nth term, how do we find the arithmetic mean? So now the arithmetic mean, which I will be representing it with am, is going to be, now it is going to be the summation of all the x variables. Are we okay? Which contains the I, where now it is going to start from I is equal to 1 to the nth term divided by the total number of variables. So here n refers to total variables. Let me add the number, total number. You just count the total number that is for our n. Are we okay? So now it is very simple. If I have, say, x1, x2, and x3. Therefore, the arithmetic mean for these three variables is going to be the arithmetic mean summation of all the x variables. That's going to be x1 plus x2 plus x3 divided by n, where n is the total number. So this is 1, 2, 3. That is going to give me 3. Is that okay? If I have variables x1, x2 up to say xn, let's take it up to xn, then my arithmetic mean am is going to be from x1 summation of all the x up to x2 plus xn divided by the n number of terms. Are we okay? So these are ungrouped data. In certain forms, you may see them in a group manner where we can have x, we can have the frequency. So in this form, I'm going to have, say, x1 making appearance of 6, x2 making appearance of 7, and x3 making appearance of what? 2. In this case, we are going to use the average mean formula, where we are going to use the mean as x. Remember, anytime you're asked to find the mean without anything attached, that's what we call the arithmetic mean. So arithmetic mean in its general term is just the mean. Are we okay? So this is going to obey the formula sigma fx over sigma f. When you see it, the discrete variables in a table form, where we are going to group it, say x1 corresponds to 6 appearance, x2 7 appearance. So here we are going to create another column, say fx, then we multiply the x value by the f to get the fx. After all, we sum the fx, then we sum the frequency. In this case, we are going to get the mean, which is also the arithmetic mean. We will see the two sides in the examples that follow. So let's start with our examples. Now, example 1. For the numbers 4 and 9, find the arithmetic mean. So we have two numbers, which is 4 and 9, and we have to find the arithmetic mean. First, I'll just write that my n is going to be 2 because it is 4 and 9. We know that our arithmetic mean, before you write it as am, try to define the term before your solution. So you can say let arithmetic mean be equal to am. Are we okay? So am is summation of all the x variables where I starts from y up to the nth term divided by n. So in this case, it is going to be summation of 4 and 9 over n. N is 2, and this is going to give us 13 on 2. Therefore, our arithmetic mean is 6.5. Are we okay? Looking at the second example, it says find the arithmetic mean from the data. So we have data 2, 4, 4, 3, 3, 10, and another 3. We are to find the arithmetic mean. In other words, just the mean. Are we okay? So straight away, I'm going to write down my data. I have 2, 4, 4, 3, 3, 10, and 3. Remember, when you're finding the mean, the order of arrangement is not necessary. You don't need to rearrange everything in order. Say the 3 should come before the 4. It's not necessary when you're finding the mean. Are we okay? So we can just do our calculation. So here my n, how many are they? We have 1, 2, 3, 4, 5, 6, 7. N is 7. So my arithmetic mean is going to be summation of all the x variables starting from 1 up to n, because we know that n is 7, so we can just write there the 7, everything over n. That is going to be 2 plus 4 plus 4 plus 3 plus 3 plus 10 plus 3. Everything is on n, 7. And with this, we are going to get 29 on 7, which is equal to 4 whole number 1 on 7. You can also change this to decimal. This is our arithmetic mean. Now let's look at this form. Find the arithmetic mean from the data below. This is a grouped form where we are saying the marks obtained to the number of students. So here we mean for 20 marks, there are 6 students that obtain 20. If you have time, you can write 20 up to 6 times, so 26, and write 25 also 20 times. But you see, it's a lot of work. So we try to group them for easy analysis. So in such instance, we are going to use the simple formula to find our mean, where our mean, which also means the arithmetic mean, represented by x bar, is going to be summation of fx on summation of what? F. Because we are using frequency to represent number of students in a tabular form, this formula is very good to go by. So I'll try to work with the same table and look at how it will go. So you redraw this table in, you can reproduce it, but for time's sake, I'll try to work with this same table. Okay, let me try it here. So I'll say max, and this is frequency. Remember, the max is the x, the frequency is the f, then we have another column, say fx. So we have max, frequency, and the fx. Nicely drawn. So 20 producing 6 people, 25 by 20 people, 28. We have 24. We have 29, that is 28. We have 15, 38, 4, 42, 2, and 43. We have 1. So now fx means multiplication, which is f times x. 20 by 6, that is going to give us what we have at fx, and this is going to give us as 120. 25 by 20, that is going to give us the value 500. 28 by 24, that is going to give us 672. This by that is going to give us 812. This by that, we are also going to have 495. 38 by 4, that is going to give us 152. This and this, 84. This by that, 43. So now we are good to go. Since we know that this is the frequency and the fx table, we are going to find summation of f, which is going to give us 100 students. Are we okay? So this to summation of fx colon, that is 2878. Therefore, our arithmetic mean, or the mean from the formula above, is going to be 2878 on 100, which is going to give us 28.78. It makes sense because here the mean, we are trying to find a location where the data is like restricted to, we have abundance of data over there. So when you check the frequency, you can see that we are having the data between, a lot of people fall between 28 and 29. Is that true? Because 24, 28. So the average student is now going to fall between 28. That's why our answer is revolving around 28. Are we okay? So this is a simple example. You can also take this example, calculate the arithmetic mean from this data. So solution, straight away you can also get your mean, where our arithmetic mean, we can list 14, 28, 9, 7, 28, 25, 13. So our n is equal to 1, 2, 3, 4, 5, 6, 7. It's also 7. So arithmetic mean, which is summation of the x from I1 up to the n on n. This is the same as summing all the x, which is 14 plus 28 plus 9 plus 7. I told you the order is not important, to rearrange them. Plus 13 over 7. This is going to give us 124 on 7, which is equal to 17.7. So this is the arithmetic mean. Thank you for watching this episode. The arithmetic mean for ungrouped data, random discrete variables, is very simple. It is the basics, so you have to understand this. In the next episode, we are going to look at group data, where we have to do some analysis. Kindly subscribe to this channel, drop your comment, and let's get moving. See you in the next episode.